Good morning, all. Let's start the session. I'm Rajesh Kushalkar. I'm heading the open source hardware under the FOSSEE project. So today our topic is for the Arduino, and we are going to celebrate the Arduino Day. So it's a worldwide event which has been celebrated. So I request all of you, if you can just turn on the camera so that we can just have a one capture of the screen. I request everyone to just turn on the camera. All schools, please turn on the camera. Thank you. So let's start our session. I just share my screen. How many of you are aware of Arduino? Can you raise your hand, please, or just say up? Yeah. How many of you are aware of Arduino? You can just give a thumbs up on the screen. Great. So let's start the session. So today's topic is Arduino from curiosity to innovation. Build, learn, and invent. So every child has got that curiosity of opening the gadgets. You take, for example, as a child, if you get a ball pen or a ink pen, the very first thing you are just going to try opening the thing, how to open it, how to fill the ink, how to refill the things. Okay, so that's a kind of curiosity, which is a very small thing that I'm talking about. It is there. Now, suppose a new toy comes in with you. The very first thing is there that you would just try to suppose it's a battery operated toy. So you just try to put a battery, how to put a battery, how it has to be placed. And once you you have played more with the toy, then you have that curiosity how the things are working. So what you try to do, you try to open the toy and see what is inside. Okay, so this is how a curious mind works, and because every child is curious and he wants to know how the thing works. Okay, and that has to be answered at a very early stage also. So once your curious mind knows and he knows how to build all these things, so future is you can build a robot, whatever is there, you can build a drone and invent the new technologies. Okay, so curious students open toy cars, as I've told you. So how does a motor works? Now, after putting the battery, now is that the motor starts moving. But there is some curiosity running in your mind that how does the motor move? What happens the moment I connect the battery and the motor starts spinning? What is inside that the motor is moving, whether it's a coil or whatever. So what's the next step? He'll always try to do is try to open the motor and see what's inside. Okay, so second example is your remote controls, what you are using at your home for the TV sets or something like that. So there are so many buttons on the remote control. So whenever you are pressing volume up button, so that time you can see the volume is increasing. So what is happening at the back? What signals that remote control wirelessly sending the signal to the television? It tells the television to lower the volume or up the volume or change the channel. So did you think over it what exactly it is happening inside? So there are 40 keys or 20 keys on your key, remote control. Each key has got different functions. So how your TV recognize each function? Okay, so this is where the electronic part comes in, where the things are programmed. Okay, and when you program it, it tells your system that once you do this volume up, the volume up signal goes and your volume start increasing. So this is how a basic system works for electronic is there. Then you write some program to it and it acts on it. Okay. So what is Arduino? So Arduino is a small programmable electronic brain. Why we call it as a brain? Because it decides the what has to be done. Okay. For example, as a human being, if I have I put a glass here, which is hot. The moment I grab the glass, I touch the glass, my skin senses something and it sends to your brain. The brain sends a signal that it is hot. You have to take out the hand from that particular glass. So what your brain is doing? It is sensing the signal. What is the input? Your hand is the input, which is sensing your signal that the glass is hot. It sends to your brain. Brain analyzes it's hot. What is the reaction? Remove your hand. Okay, so that's a reaction. So it's a small programmable electronic brain. So which reads some sensor value. Your hand was one of the sensor which senses things. It controls. The brain tells it to remove your hand. It controls the thing. So blink of LED, build robots, that we'll definitely talk further also. But this is what exactly is about sensing a device. Now, Arduino, as I told you, Arduino is like a brain. The sensor, Arduino, takes an action. For example, temperature, Arduino, fan turns on. Now, there are various kind of sensors. Now, just take for example, how many sensors that we have in your body? Touch sensor is there, as I've told you. Okay. Then your eyes is there, your hearing is there, your smell is there, your taste is there. Okay. Your mouth is another speaking is there. So just try to resemble the sensor that you are trying to do it with your phone also. Okay. Eyes is your camera. Okay. Earpiece, you are listening to here, it's a speaker out there. So whatever you are speaking, microphone is there. Okay. Your touch screen is there. So these are the various sensors which have been man-made. I'm talking about what are the human sensors and what are the man-made sensors. So there are a lot of sensors available in the market and which have been widely used for detecting various physical environment. For example, the physical environment, suppose it is a temperature I have to sense. There is a temperature sensor available. Okay. Now, what this temperature, I am trying to write a program for Arduino saying that if the temperature, room temperature goes above 25 degrees Celsius, then the fan should turn on automatically. So what is the input? Temperature is the input. Just like I've shown my hand, the moment I try to touch a hot glass, that's the input. Arduino sends something to, like a brain senses that it is hot, you have to remove that thing. So Arduino tells now the temperature has gone above 25 degrees Celsius, turn on the fan. Okay. So you see what is the sensor input is taken and some output you are trying to do with this thing, trying to control something. Then again, if you see the Arduino and temperature sensor, so if the temperature go below certain value, for example, if it goes below 23 degrees Celsius, automatically the fan should turn off. So what happened if a room temperature is there now 23, 24, 25, it reaches, the fan starts moving because it is done automatically. The moment the room temperature drops below 24, 23, 22, the fan stops. Okay. So you understand this process has become automatically. So how, for very first example of a hot glass that I have told, the reaction remove is done controlled by your brain. It is done automatically. Okay. Same thing is there for your Arduino also. So this is the way where you program it. So real life example, Arduino can do smart irrigation, robots, home automation, weather station, air quality monitoring, and drone controller. So what is smart irrigation? For example, you just take for your home plant. So every pot, you generally what you do, you try to put a glass of water in each pot. Every day you are putting, whether it is required or not required, you are just putting the water in it. Okay. But if you have some sensors it is called as soil moisturizer sensor. If that is put near the plant, it senses what is the moisture of a soil. According to that, the sensor tells your system, Arduino, for example, okay, now I am feeling thirsty. The plant says I am feeling thirsty. Please water me. So how the water is doing? He is not going to come and put a glass of water to it. He will just turn on the motor, and through pipe the water is dripped in each plant. So each plant, how much water is required? The moment the soil moisture level has gone above certain level, which has been described in your program, automatically the motor stops. So what is you can see here, you're not unnecessarily watering the plant. Whatever it is required, that much you're watering to it. Okay. So whenever and how much it is required, that much water is being supplied to the plant. Okay. So in this case, how you're trying to conserve the water also. Okay. Unnecessarily all the minerals. Same thing if you just look at the huge farm, the farmers are there. Just pour off a water, but what happens? All the minerals which are there on the soil above and all this thing goes down. It just pour away from the soil. Okay. So to prevent all these things, so you have got this called as drip irrigations and all these things. So this is also called as smart irrigation. Okay. Many further, if you just try to go, the drip irrigation is there, how much water is required, what is the humidity level, what is the temperature of the farmland and all these things. All these things are there in the smart irrigation. Now I'll just come to the home automation. Now you must have seen a simple example of Alexa. The moment you say Alexa, turn on the light, Alexa sing this song or whatever is that, it connects to the internet and do this part. Now same thing, whatever I'm talking about, this small temperature sensor, small device, the moment this small devices is connected to internet, the moment these small devices are connected to internet, it is called as Internet of Things, IoT. Okay. So this device, the moment it connects to internet, like I'm talking about the home automation now. Now we are talking, turn on the light, turn off the fan, whatever is there, we are just speaking like that it is doing. Suppose I'm outside the house and I'm just trying to say, I'm just calling my home automation tool that I'll be reaching home. I want a room temperature to be so and so degrees Celsius, pleasant temperature should be there. Now, what my home system does, it checks my present location, how much time I'm going to take to reach home. Suppose it takes half an hour to reach home and the system, the home AC or this thing is required only 15 minutes to cool to whatever temperature has been set. So it is not going to turn on the temperature immediately. He gets the thing. The moment I see he's coming near, it is going to take another 15 or 10 minutes. The AC will turn on automatically, and the moment you enter the room, you will have the pleasant room temperature. Same thing is there for your weather station. What is the weather station generally mainly deals with is what is the temperature and what is the humidity of your site. Nowadays, there is a lot of issue, we call it as air quality. So you have to check the quality of your air, how much small particles, because a lot of constructions are going on in your nearby area. So there is something called as small PM 2.5 per sensor, which takes very small amount of very small particle which goes in your lungs and bloodstream also. So that it takes and says, yeah, this is the level of PM 2.5. in your area. So try to cover the things, so whatever is there. So these are the various things that one can do. Now, why Arduino is popular? Arduino is popular because it's a very low cost device. It's a small prototype board. It's a very low cost device. Let me see. So as you can see, this is the Arduino. This is such a small device, and you can use this thing for your programming. Now you can, as you can see, there are a lot of pins available on it. So this is called as I/O, input and output, input output. So there are some digital pins and there are some analog pins. And to program it, you program it through the USB connected to your computer. So this is a very small device where you connect. We can show you certain examples also and how you can learn these things. This is a very small, cheap device available for basic prototyping, and it is widely used throughout the world and very perfect for the students, for a beginners to learn the electronics programming. Now, why to learn Arduino? The skills that you could learn with the Arduino is not only design, thinking, problem solving, but coding also. You are trying to innovate something. So what is design thinking and problem solving? So very first thing that you have to think, what is a problem is there. You can't just directly jump to the design or come out to for the product or something like that. Now you just take for example, the very first Edison has invented a bulb. But why he has invented a bulb? Because he saw a lot of problems of kerosene lamps. Lamps get this thing, air pollution is there. A lot of issues were there in the closed room and all that. And not much light is also not been given. So that was a problem. That's why Edison has invented a bulb which gives you a very bright light. The whole room is fully light and everything. So problem statement is always required. I'll give you a very small example of a problem statement here is for your classroom. How you can automate your classroom attendance system. Okay, how many students are coming in, how many students are absent and all this thing. Rather taking on a pen on a master roll or something like that, how this thing can be done. Okay, so this is a problem. Now you will, after this problem, you will try to design something on it. You will have some brainstorming session how to design this thing. Then you come say, these are the few electronic parts it is required. Then what you are going to do? You are going to do very first thing. Always try to do is a simulation. Our Pratik will definitely show you the different simulation tool that we generally use it before going for any making this with actual Arduino. So always use a simulation tool, do the coding in the simulation tool, and see the output whether you are getting a satisfactory output or not. Because once you get all that thing properly, then only you are able to go and make the circuit. So this session is mainly focused that whenever you want to try to build a lab or try to build an Arduino lab or a tinkering lab or a Atal tinkering lab in your school, you can use the tools which are developed by the FOSSEE at IIT Bombay, where you don't require any physical Arduino with you. You can learn programming, you can learn coding, you can do the wiring and everything online on a simulation mode. And after that, you can learn the coding also. Now, the same thing is going to work physically also once you do the wiring and all this thing. Okay. So future technology, Arduino is widely used for robotic engineering, IoT developers, electronic engineer, AI hardware engineer, and startup and founders and more. So these are the few careers, and now space and technology, everywhere it is used. Smart cities are talking about, now smart cities always talk about proper sanitations or proper, you call it as traffic management, the air quality of the city. Now you see at a corner of some places there's a garbage is just filled, but there's nobody to collect it. But if you have a smart bin, smart dustbin which has been made, which tells the corporation that yeah, so and so bin is full, you please come and collect the things. So that data is going to the corporation and it is telling that no, this particular area the bin is filled, you have to come and clear it out. Okay. So this all things, small devices, you can try to program. The moment the small device connects to the internet, it is called IoT. Now same thing for the space technology or smart city or agriculture technology or medical technology, whatever is there, everything comes through the IoT based things only. Okay. So input and output, as I have told, input is the information given to the system. As I have given the example of temperature sensor is an input. Similarly, microphone is an input. Any sensor is an input. Now you turn on the fan or light. You turn on the switch. The switch is an input and output is fan or light is turned on or off. Okay. And output. The output, as I told, the switch is the input, light and fan is the output of it. So similarly, any indicators, temperature has gone above this thing, fan is turned on, or if you want to turn on the buzzer, that also can be done. So that are output. Simple example, as I mentioned, button, Arduino and LED. So you have tried to program the Arduino in such a way that it is going to turn on the motor or light at that particular time, which has been defined. Same thing for the soil moisturizer sensor also. If the soil sense the moisture level is very low, please water. So automatically the water pumps is turned on and the water is poured into the pots. Now another example for your school tank. Now school tank, what happened? Your watchman or somebody goes to the tank and see whether how much water level is there. Okay. Now if he sees now water level is hardly at 10%, now I'll go down and turn on the pump. And after half an hour or 40 minutes or whatever time, he will come again and check it how much it is filled. Then go back again down and turn off the motor. Okay. Many times it happens that the tank becomes overflow and a lot of water has been wasted. But what if I do this automated? There are certain levels of water level has been detected. Yeah, 90% the motor is off. But if water drips to 20%, okay, the automatically the motor will start and it will start pumping the water. Now as the water level rises and it reaches around 90, 95, it sends the signal back to the motor to turn it off. So how this thing is done now? Automatically. Now there is no wastage of water also. No, the human person going up and trying to check every time it is stopped. So you can see how we can try to automate major of the things. Before going for the demonstration, I would like to show you some more thing. This is a small video for a curious mind.
Danish was not an ordinary schoolboy. He was curious about how things worked.
Why does the fan spin so fast?
Good question, Tanish. Let's find out together.
At home, his curiosity turned into action. Every broken gadget was a new mystery waiting to be solved. One day, Danish discovered something amazing: Arduino.
So code can control real things.
With patience and practice, Danish built his very first robot.
It works! Wow! Where did you buy this robot? I didn't buy it. I made it.
That one sentence changed everything.
Can you teach me? This is called the Blink program. Every journey starts here. Press the button. I did it! The LED turned on.
Step by step, curiosity turned into confidence.
Wow! We're controlling it wirelessly.
Together, they built more than projects. They build skills.
Next, drones. Yeah, drones.
Years passed, but curiosity never faded.
Remember our first blinking LED?
And now, drones for the nation.
To curious minds, one open source tool, a stronger nation.
This robot helps us learn about science.
Yes. So myself Pratik Bosle. So we also have this video where we have used Arduino sensor and all the other controllers to create projects that we will demonstrate you right now. So it is a 5-minute video. So this is a game where you have to press the push button for that particular LED. It is a memory game. So what it does is whichever LED lights, you have to press that push button, and it checks your memory. So if you do that, and it will just get difficult. But as soon as you press the wrong push button, you will see here, I have pressed the wrong push button. It starts again. So it is a memory game basically. Then we have a wireless robot which we have used with the Bluetooth sensor that we can just control it with the application. Here is a digital sand clock. You must have seen a clock where it is used, the sand is used as a timer. So instead of that, we have used 8x8 matrix, LED matrix, to a couple of them. And in a minute, it drops just one by one LEDs. And you will see if I just turn it around, uh, one by one the drops will come out, and it will count in as 1 minute. So it takes around 1 minute to complete this process. So it basically replaces the sand clock that we generally see in movies. Then we have a automated movement robot. So you must have seen the automation industry where you just have to program the machine once, and it repeats its work. So here what I'm doing is I'm ordering the machine to perform certain tasks and with angles. So right now what I'm doing is I'm giving the object to the motor, which will just pick that object and then turn it around and drop it into the black box you can see on the screen. So I'm using servo motor and potentiometer to control it. You can see I just have to do this process once. I have to guide the system only once, and once that is done, I can save this instruction and ask the motor to run it over and over again all the time. So you can see I have just demonstrated the experiment once, but the servo motors connected to it have just collected all the information and doing the task again and again. Then we have a RGB Guardian game. So we have a LED strip which is sending out number of colors of LED, red, green, and blue, and we have push buttons connected to it. So what we have to do is whichever color the LED is coming from the LED strip, we have to press that and kill that LED. So that way, so it is a level up game. So when you do that over and over, you will have difficulty levels in the game. And if you are not able to delete or the kill the LEDs, the game just restarts and it starts from stage 1. Okay, so what we will do now is, I think my screen is sharing. Screen share. Huh. So whatever, so Rajesh sir told you that we use simulation platforms. So this is one of them, electroblocks.org. I will just share this link in the chat so that those of you who have the access of computer or system, they can just log into this and just while I am explaining the system, they can try to replicate and demonstrate on their own PC. So this is the electroblocks interface. What we do is we try to teach students from the basic. We don't want student to at the start. We don't want student to worry about the circuit connections, writing the code for the controller. What you have to just focus on is logic. So suppose I want to turn the LED on, I just have to figure out what are the blocks that should be using. So in here we have certain logic level blocks that will be used for the coding, and in the add-on section we have Bluetooth sensor, digital display, LCD screen, LED, passive buzzer, RGB LED, servo motor. All those are components. And in the sensor section we have analog, digital sensor, motion sensor, temperature sensor. So let's just start with creating a simple experiment of blinking an LED. So what does the blinking of LED means in logical terms? So it is basically turning on the LED, keeping it on for a certain amount of time, then turning it off, and then keeping it off for a certain amount of time. So for that we need an LED block. You can see in the add-on section there is a block named LED. You just have to click on it. In the first block is used for the turning on the LED. You can just drag it outside in the canvas, so you can see whichever block you want to be used in the experiment, it has to come inside the loop block. So as you can see, since I am placing the block outside the loop block, it is turned to gray. And on the right hand side you can see a breadboard and Arduino on the screen, but there are no LEDs. So you can see the change as soon as I bring this block inside the loop block, you will see an LED inside the simulation screen. You will see the red color is denoted here and the red LED has been displayed. So we can change the color of the LED as well. We can make it green and you can see the LED color changes to green. We have the option of changing the pin number as well. So as Rajesh sir mentioned that there are IO pins. So digital pins are from 2 to 13, and we can see we have an option of the numbers of the Arduino pins. So you can connect to any of the pins. You can select, let's say I'm selecting pin number 4. So you can see the number has also changed here. I'll just zoom it in. You can see the number has changed here and it is connected to pin number 4. So let's say I want to connect it to pin number 8. Again it changes Again, the denotation is pin number 8 and the pin is connected here. So this is for the turning on the LED. So we want to also want to make sure that the LED stays on for a certain amount of time. For that time block, in the time section, we have to drag the wait block outside and place it just below the LED on block. So this is where the controls come into the picture. We can control the amount of time we want to keep that LED state on. So we can change it to 1 second. So what this will do is this will turn on the LED and it will keep it on for 1 second. Now we want to turn off the LED as well to bring the effect of. So we will again go to LED, bring this block out. So what is happening right now is you can see there are two LEDs. One is green and one is red. So the reason for that is we have selected pin number 8 here for the first LED block, and for pin number 2 for the second LED block we have selected pin number 2. But since we want only one LED to be controlled in the blinking pattern, so we will change the pin number here, and as soon as I click on the pin number 8, you can see the second LED that just appeared will vanish and we will only have one LED. So you can see the LED only one LED has been connected to pin number 8. So that is done. We want to change the state of the LED now. So at the start we have turned it on, then we have kept the delay of 1 second, then we will be just turning off the LED, and again we will connect the wait block here just below the off block, and we will keep it 1 second. So this pattern will what this pattern will do is it will turn on the LED, keep it on for 1 second, it will then turn off the LED and it will keep it off for 1 second. So I will just start the simulation here with the play button, and you can see, you'll be able to see that the blinking pattern appears on the screen. So you can see it is turning off, turning on, and it is doing for three times. So why 3 times? Because in the loop section we have mentioned that whatever the experiment is, it will run it for 3 times. So let's say I change it to 5 times. So what this will do is it will turn on and off the LEDs for 5 number of times. You can see the it is highlighted here, loop 3, loop 4, and at the last it will end in loop 5 block. So in the simulation aspect, we can control the amount of time the LED can be blinked. But when you go to the hardware section, you once you upload the code, the Arduino will implement the code onto its component for n number of times. It is just the simulation part where we can control the amount of time the simulation can happen. So on the back end, so as we mentioned, you just have to worry about the blocks. You don't have to worry about the circuit connection. And here, as soon as you enter the blocks, the ElectroBlocks platform on the back end generates a code for you, the Arduino code, which you can use to replicate this experiment hardware when you have the hardware components. So let's try to see how the code is generated. So I will just put one by one. I will just put the blocks one by one. Before going to that, I will just have to explain what this does. So this is the basic syntax of Arduino. Void setup is where you mention whichever component or sensor you'll be using in that particular experiment, and you mention it here in the void setup. And in the void loop, the actual code is written here. So suppose in the LED blink, we write the LED will be turning on and turning off. So as soon as I bring this block inside here, you will see a line appears in the void setup loop. So what it does is it denotes the pin number and it denotes what kind of component we have used. So since an LED is an output component, we have written the code has been generated as output, and it configures the LED pin which is connected to pin number 8 of Arduino. And in the loop block, you can see a digital write 8, high is written. So what it does is the component, in this case LED, which is connected to pin number 8, it has been turned on. When we add the wait block, you can see a line is generated here, which is a delay bracket 1000. So in Arduino, 1 second delay is equal to 1000 milliseconds. We don't write in terms of second, we write in terms of microseconds, milliseconds. So when we add the third block, you will see the same line digital write, but in this you will see a low command. At first we have written high to turn on the LED, then we are writing low to turn off the LED. Then we will just bring the last part, a wait block, and you will see a delay 1000 is written here. So when you get a hang of it, this electro blocks also provides you the feature of when this code is generated, you can upload the code to the Arduino hardware as well. I have a hardware setup with me right now. So what I will do is I will just connect the hardware setup. And in this you can see this section, we have a upload option. So what you have to do is you can connect your Arduino using the Arduino cable to your system, and once your experiment is done, once your simulation is done, you can upload the code here, select the port, and once your code is uploaded, you will see a message on the screen that the code has been uploaded now. And you can see here the LED is turning on and turning off. So we can actually control this. What I will do now is we can change the amount of time the LED should turn on. So we can keep it on for 3 seconds, and we can let's say we can for the 0.5 second we can turn it off. So what it will do is it will turn on the LED for 3 seconds and it will turn off for 0.5 seconds. And as I mentioned, in the simulation, there is limit till where you can actually see the simulation running on number of times. But in the hardware, when you actually connect to the hardware, once the code is uploaded, the Arduino will implement its code for n number of times. So you can see the LED is turning on for 3 seconds, it is turning off for 0.5 seconds, and the loop continues. So there is no limitations where you can it will just run n number of times. So how many of the students are doing the actual work in the simulation platform? You can just raise the hand or unmute yourself. Dhanu Mude, okay. Sir, you can unmute yourself and you can answer. Okay, you want to increase the block size. So is it visible now? I think it should be fine. Okay, we will just give 2 minutes for participants to get the hang of how the LED blink experiment works. Then we will move on to the next experiment. If you have any doubts, any queries regarding this, you can just raise your hand or type it in the message section, or you can unmute yourself. And yes, Namita Janaikar, you have any doubt? You can unmute yourself and you can ask the question. Deepak sir, can we unmute him, or he has to do it himself?
I give the permission all unmuted.
Okay. You can just, Namita Janekar, you can just unmute yourself. There will be an option on the bottom of your screen where the mic symbol will be coming. So you can unmute yourself. Yes, yeah, yeah. Or else you can write the question in the chat box, so that if anyone else has the same query, we can answer them.
Sir, am I audible?
Yes, yes.
Sir, I want to ask that in my code, it is written while true and time slip, etc. Those terms are written.
While true, so you must have, so for the starting you don't have to use any logic code. What you can do is, you can just, I have just made it large enough for you to see on the screen, that for LED blink we have used only two blocks, two kind of blocks. One is LED and one is wait block. So you can try to replicate it and see
Sir,
for
I have
yourself.
used the same, but still.
Can you share your screen then? I'll have to stop sharing, I guess. No, no, on the computer itself, you can share your screen. In Arduino memory game, what does the
Sir, it
player?
is written you are not allowed to share your screen.
Okay. Deepak sir, can we give him your permission? Okay. So one question has come. Neelam Mishra.
Yeah, he can share the screen.
In Arduino memory game, what does the player need to remember? Okay. So in terms of Arduino, the memory game. So the idea behind is, so suppose there are 5 LEDs of different color that are on display, and the system actually generates a random sequence of LEDs to be turned on. So let's say number one LED is turning on, and I remember that, okay, one number LED is turned on. I can press the push button associated with it. So like on it goes on till, let's say, 5 or 6 LEDs. But after a certain number of times, there is a possibility that you can actually forget the sequence of LED that has been turned on. So it just checks your memory of how many LEDs, how many sequences you can actually remember, and try to implement the same with the LEDs, with the LEDs and push buttons, which is associated with that particular LED. Okay, so I think you have shared your screen,
Yes,
and
sir.
okay, so you see the in the, no, you can just go back to the later blocks page, the later blocks tab. Yeah, on the right hand side you can see there is an option of selected language, and there is a Python option. So you can just, yeah, you can click on it and select C. So now the code will be turned to C. We have an option of writing the Python code as well. But for now, since you are just entering into the phase where you are learning about the Arduino and writing the code, we want you to focus on C language, which is generally used for Arduino hardware.
Okay,
Once you
sir.
get, yeah, once you get used to it, you can actually, or you can definitely switch back to Python language as well.
Okay, sir.
Yeah, sure, no issues. So let us just move ahead with the next experiment. So what I will do is, so let's say we want a system where we are turning on the LED, but it is in our control. Let's say in terms of whenever you go to home, obviously it comes into the AC domain. This is a DC domain. It all works on the DC circuits. But let's say you want to turn on the light inside your room. What you do, you first go to the switchboard and you press the button, press the switch, only then the light turns on, right? So we will just try to implement the same experiment here. I will remove these blocks. And how does the logic work behind it? So since you don't have to worry about the code, you don't have to worry about the hardware of it, you just have to make sure that your logic is right. So to turn on the light, which is controlled by a button, what do you need? You need a button first, right? So if you drag it down in the sensors part, you will see a button option. Just click on it. You can just drag this button setup block outside. Chat. Okay, I have a query. Okay, can we come back to this question again? I will just explain this part, and I will definitely answer you on this one. Okay. So as I was saying, if we have to bring the button setup block outside, and you can see it is connected to pin number 2, and you will see a button animation here, which is pressed. So now what we have to do is we have to uh, add a logic level block, which will check the condition first, whether it is true or not. So for that we need if then block. So I'm placing the if then block inside this, and then I will check. I will go to button block again, and I will bring this block outside. So it will check whether the button is pressed or not, and I have to place this block in alongside the if statement. So it will check whether the button is pressed or not, and we want the light to be turned on only when the button is pressed. So I will go back to the LED. I will bring this block out and place it in the then section. So you will see a error message appear on the screen. So the reason behind is the button is also connected to pin number 2, and you are using the LED, which is automatically connected to pin number 2. So for that purpose, all the blocks which are connected to pin number 2 have turned to gray, and you won't see any component or any sensor here. So you have to just change the LED pin number. You can change it to pin number 8, and see as soon as you change the LED pin number to 8, you can see all the sensors and components appearing on the screen. So now the LED is turned on when the push button is pressed. So we want to make sure the LED remains off in off state when the button is not pressed. So we will just place this off LED block. And make it off. So what this checks is when the button is pressed, the LED will be turning on. So we will just play the simulation here. You can see a hand is here to press the push button. I will add a delay for your reference. So to make sure that you see the block. Okay. So it will turn on the LED and it will stay on for 3 seconds and then it will turn off. So I'm starting the simulation. You can see a push button is pressed, a pressed message is coming on the screen, and the LED is turning on for 3 seconds. So this is happening because we have given in the button setup section that the condition which is button is pressed is true. So what happens when the condition is false? You can see as soon as I uncheck this box, the hand which was there earlier, it has disappeared now, and a message that it says that release. So this message is in concern with the push button. It says that the button is released now, and when I play the simulation, you will see there is no blinking, there is no turn on of the LED because this condition is not met. When the button is pressed, only then the LED is turning on. But since that condition is not met, it is directly going back to the LED turn off. So I will just check this box again. You can see the hand comes here near the push button and a pressed message appears on the screen. And you can turn on the LED in the simulation part. Right. So just below this simulation screen, if you just drag it the bottom screen again, you will see we have given a stepwise explanation. So like we have an option of going step by step ahead. So since I'm pressing the next step button, you will see the execution step which is appearing on the simulation screen is highlighted here. It is also highlighted in the loop block as well with the yellow color, that at this time this block of experiment, this block of code is executing. So we have this option. You can see I'm pressing the next button and it is showing which line of code is actually in the place. So I asked the students who have the system with them to replicate this experiment on the screen, and if they are done in, let's say, 3 to 4 minutes, they can share their screen and let us see their experiment. Yeah, I think Shaurya Saxena had asked the question regarding Acha. Pratik Nemani, my colleague, has actually answered this. So if you have any doubts, do not keep it to yourself. I urge everyone, if they have a doubt, they can ask in the comment section, or unmute yourself and ask them, because it might be the case that any other participants will also be having the same query, and just by answering your own question, I'll be answering everyone other's query as well. So do not shy. You can ask the question in the chat box or unmute yourself. Neelam Mishra has raised their hand, I guess. Yes, Neelam. Yes, Neelam, go ahead. You can ask the question. So what you can do is, you saw how I did the Arduino experiment, the blink of LED experiment. In the same process, on the screen you will see the blocks which have been arranged in a particular manner. It is to control the LED using the push button. Yeah, so you can try to replicate the same. Okay, Neelam Mishra has asked, what is the variable and why is it used in the Arduino program? So variable is something which you will get to know once you complete the basics of Arduino, the coding. It is where it is a register kind of a place where you store the value. So that is how the counter experiment is done. If possible, I'll be able to show it to you. Or do we have the counter experiment? Counter experiment आएगा variable. Yes, Neelam. I will explain after this. I will explain how does the variable block works. So it is generally the current state of the experiment, the current state of the Arduino or the value that is saved in the variable, and you will understand why variable block is necessary. On the right side, the board, the whiteboard, it is called breadboard. It is used to connect all the components on the breadboard. So you don't want all the components to be hanging around or just lying on the surface. So that is the reason this component is there, breadboard. So you can see, if possible, I will just let you.
Pratik, you are on mute. Pratik, please unmute yourself. Pratik, unmute yourself.
Yes. So you can see this is a sample of a breadboard. All these lines which are colored in orange, those are used for power supply, the connecting positive and negative. So these are internally connected. So once you connect a pin here, all the lines. So suppose you connect a positive 5 volt here, all this entire rail becomes positive. And in terms of these lines, the lines from A, B, C, D, E, these 5 lines are internally connected. So when you connect one line, suppose an LED here, you have all the four options for you to connect the wire to the Arduino or any other controller. So that way, breadboard is used to make sure it is easy for everyone to connect the components and sensors to the Arduino. Okay. Can we type code as well on the website to make a so electroblocks is used just for the block based coding. The code is generated on itself, but we have another tool, another website which is called Arduino Cloud. There I will just demonstrate in a few minutes. There we can actually implement this part. So the idea behind this is, using the electroblocks, you first get the feel of how the simulation should work, how the code is generated in the backend. And once you are comfortable with it, then you go to the Arduino Cloud website. There you have the option of writing your own code, doing your own circuit connections using the controller and components. So coming back to, I think someone has asked the question of variable, right? So Let me check if I have the experiment. Okay. So you can see this is a RGB LED experiment where what it does is when the button is pressed for the first time, the LED, the RGB LED has three colors, red, green and blue. And when the push button is pressed for first time, only the red color will turn on. When it is pressed for the second time, the green LED will turn on. When it is pressed for the third time, blue LED will turn on. So this state will keep on going, and when the button is released, so it is for the hardware. When the button is released, no color will be turning on. So you can see this part, the number count block. You can see. So this is a variable block. So whenever your experiment has something to do with holding the current value and implementing certain tasks depending on that value, that is where variable comes into the picture. So it stores the value of that particular task and then performs the next task depending the variable value. So I can just play the simulation for you. You will see for the first time LED pressed, red LED turned on. For the second time, green LED turned on. And for the third time, blue LED turned on. So I'll just start it again. So you can see the LED here. You can see the push button here. And just here, when I will start the simulation, you will see the count number. So depending on the count number, the color of the LED decides which light to be emitted. So for the count 1, red light turned on. For count 2, green light turned on. And for count 3, the blue light turned on. So like that, this is where the variables come into the picture. So in here, in the project section, we have multiple projects which have been demonstrated by us. So you can use it. You can try it on yourself. So since one of you had asked the question of actually having the liberty of writing the code, I will just go to the simulation.fossee.in. I will share the link as well in the chat box, which will make it easier for you. So simulations.fossee.in is the website, and I'm sharing the screen right now. So this is where Arduino on Cloud is here. This is the landing page of the simulations FOSSEE website. When you click on the launch button, this page will come on. You will see there is an option for explore experiment and the launch editor. So let us just click on the explore experiment tab. Here what we have done is we have given the number of experiments that will tell you how you should be doing the experiments on the cloud platform, where you can connect the Arduino to the sensors and write your own code. So let's just take an example of temperature indicator using RGB LED. So at the start, we give the aim that to learn how to detect the temperature with RGB LED using Arduino and TMP36 temperature sensor. So this is the aim of this experiment. Then we come down to components which are required to complete this experiment. There is Arduino board, breadboard, temperature sensor, RGB LED. Then what is the actual sensor or component that we will be using? And we give the brief information about that particular sensor. Then we provide the circuit diagram as well. so that you can try to replicate the same circuit diagram on your system. And yeah, so you will have the liberty of connecting all the dragging the breadboard, dragging the Arduino, connecting this temperature sensor, connecting this Arduino, the RGB LED. In here we have given code for this particular experiment. Yeah, and the code has also been explained. So let's say you are finding it difficult to know what the line of code is actually doing. So line by line we have demonstrated what this line of code is doing to in this experiment. And at the bottom we are giving a small video of the output experiment, that this is what the expectation are of this particular experiment, so that you can compare it with your own experiment, own result, and you can cross check it with the given output. And once you are comfortable, like once you have gotten hang of what you have done in this experiment, we are also giving the assignment here. So you can, once you are done with the experiment, you just have to change few things in your circuit, which will complete another task. So going back to the cloud platform, you can just click on the launch editor. So this is the UI of the Arduino cloud platform. You can name your experiment. Let's say I'll name it as blink of LED. On the left side in the panels, we have breadboard, resistors, controllers. For controllers, for now we have Arduino Uno. In the output section, we have buzzer, LED, motor, RGB LED, servo motor. In the input section, we have push button, ultrasonic sensor, which is used to detect the object, the distance between the object and the sensor, PIR sensor, potentiometer. These are all the sensors that we have. So let's try to replicate the same experiment of blink of LED in this Arduino cloud. So whatever component we needed for the blink of LED, we have given here. So we will just click on the blink of LED. So the components which are required for this experiment are Arduino Uno board, breadboard, LED, and resistor. So these are the 4 components that we will be using. So first we will drag the breadboard out. We will keep it here. Then we need an Arduino Uno. We will just drag it like how you do in the ElectroBlocks platform. Dragging the block, you just have to drag the component here. Then we need an LED. In the output section, you can find an LED. You can place it here outside. And you also need a resistor. So you can see there are multiple pins on the Arduino. So as I mentioned, so this will be a clear example for you, I guess, to understand how the breadboard works. I've just largened my screen. You can see, since I'm connecting, like hovering the pin here, the mouse, you can see this green strip of lights are coming on. So that means these lines are internally connected. So first line is internally connected, second line is internally connected. Same way, these lines are connected. But when you come to the center part of it, these lines are connected. So these are connected vertically and these are connected horizontally. So in practicality, wherever there is a power supply of 5 volts, 9 volts, or 12 volts, we prefer to connect it here, so that you have ample number of pins for any other sensors. And whenever it comes to sensors or components, we connect to this section. So you will see, yeah, so what we will do is we will first connect the ground pin. What you have to do is you just have to take your cursor to the ground pin, move it ahead, and just try to connect to the dots of this line. So this will create your ground rail. Coming back to the LED, you will see there are 2 legs of the LED. One is positive and one is negative. So the negative leg, the negative LED, the negative leg of the LED will come here, because this line has been connected to ground pin of Arduino, and the positive leg will be connected to the pin number 12 of Arduino. You can choose any pin from pin number 2 to pin number 12, but it has to go through a resistor. The reason for that is 5 volt is a bit higher for a LED, and it can damage the LED. I can just show you the example. So suppose I am connecting the LED directly to pin number 12, and let us just write the code for it. So as I mentioned in the electro block section, in the void setup, we define what pin is used and what is the mode of the sensor, whether it is input or output. So since we are using the LED, we will use an output. So we will write the code. Pin mode, it is connected to pin number 12, so we will write 12, and we are using the LED, so we will write output. In the void loop where the actual code will be written, so we will write the code to turn on the LED. We will give a delay of 1 second. Then we have to turn off the LED as well. And again a delay of 1000 milliseconds. So what this will do is it will check the code whether it is right or wrong, and it will run the simulation. So in here we have an option of start simulation. You can just click on the play button. It will buffer for some time. As you can see, a message has been updated here that the LED has been burst. The reason for that is, as I mentioned, the 5 volt coming out of the breadboard, coming out of the Arduino, is a bit on the higher side for LED. So that is the reason to control the current. We use a resistor. So what we will do is we will connect to this the positive leg of the LED to resistor, and then complete the circuit by connecting it to pin number 12. So now we have connected the positive leg of the LED to pin number 12 via resistor. So the code remains the same. So there is no changes in the code. And let's now try to simulate the circuit. So you will see the LED is turning on for one second and turning off for 1 second. And in the bottom, this screen, you will see a message that a message will appear in the green color. It first compiled the code for Arduino Uno, and a message appearing in the green color indicates that the code which have been written by you, the syntax of the code is right. So suppose I make, as a student, I make a small error in writing the code. Let's say there is a semicolon which is required, keeping in mind the syntax of the Arduino. Let's assume that I forgot to write the semicolon, and then I try to simulate the code. What it will do is it will check the Arduino code, and it will give that there is an error in the void loop section. So since we had deleted that semicolon from the void loop section, you can see an error message highlighted in the red color is appearing. But as soon as we do, like we correct this part, the message will appear on the green color, indicating that the code is right now, and you can actually see the output here. So you will see there are, so suppose, so since for this experiment there are only 2 lines, 2 wires that have been used. but there will come a point where you are using multiple experiments or multiple sensors in the experiment, and for that you will need to you should be able to change the color of the wire. So let's say we want to change the color of this wire. We will do is we will just click on it, and a pop-up window will appear on the screen, and then from here you can change the color of the LED, the color of the wire. uh, Likewise, you can select this wire and change the color to red. So this way we can have multiple colors of wire in the experiment. And since you can see it is not properly aligned, the wires are not properly aligned to Arduino Uno or to the breadboard, we have an option of auto arranging the wires. We have to just press it once, and it will automatically turn like realign all the wires aesthetically for you to understand clearly the pin configurations. So, how many of you are doing the simulation for Arduino on Cloud? You can raise your hand and or unmute yourself. Okay.
Hello, sir.
Yes, speak.
Sir, in the void section, don't we have to add resistor since we have used resistor as well?
Resistor won't be added because it is a component that is used to limit the current. It does not actually do anything in terms of controller. So yeah, in the resistor won't be mentioned in the code.
Okay, sir.
Yes. But keep in mind, you have so resistor won't be mentioned, but in the next experiment, I will show a potentiometer experiment. For that, the those values are to be whenever we want to control anything based on the value of the potentiometer, which is also a resistor, then we have to mention the potentiometer. But right now we are using the resistor just to control the current. That is the reason we are not mentioning any value for the resistor. So LDR sensor is a light dependent resistor. It detects the amount of light falling on the sensor, and depending on that, you can control the light of the environment. So shall we move ahead with the next experiment, or should we wait for 2 more minutes? Okay. So we'll move ahead with the next question. So coming back to the this UI, so we have a code section here. We have a start simulation button where the simulation, when you press the button, the simulation will start. These are the undo redo buttons. You can actually download your experiment uh, and import it as well. You can save this experiment temporarily on the system that you are using. It will just save the experiment for the time being. We have a delete option here. You can select a particular component. Let's say I'm selecting this wire, and I can select the delete button. The wire will disappear on the screen. So here we have gallery where we have multiple experiments already available. So one good question from student, that don't we have to mention about register? So coming back to this, I will use this experiment as an example where we will be controlling the servo motor rotation based on the value from the potentiometer. So I will just first show you the code for this. So as you can see, a library for the servo motor is used. Then in the void setup, servo motor is mentioned. And coming to the loop block, this analog value. So you can see the potentiometer is connected to pin number A0, the analog pins of Arduino. Then that is mentioned. The reason for that is the analog values are typically range from 0 to 1023. So they have 1024 values. So depending on the lowest and maximum value of the potentiometer, the analog value detected by Arduino changes, and it varies from 0 to 1023, 1023. And we want to control the servo motor rotation based on that. So that is the reason this analog read for the potentiometer has been mentioned in the code. So we will just start the simulation. So you can see I'm controlling the potentiometer, and depending on the value from the potentiometer, the lever of the servo motor is also controlled. So for the starting position, let's say it is at 0 degrees, but since I'm increasing the value of potentiometer, it is changing the position of the servo motor as well. So we have another example, the LCD example, where what we will do is, yeah. So this is LCD breadboard. So here, what we have done is we are writing on the first line we are writing simulations, and on the second line we are writing on cloud. So the message will be simulation on cloud. So we'll run the simulation part, and you will see that the words which were written in the code are appearing on the screen. Simulation on cloud. Let's say we want to change something on the screen. We want to display Arduino on the first line, and on the second line we want to write Arduino day 2026. So let's see whether it implements the changes in the code. So you can see the changes that we made in the code has been reflected into the hardware as well. It is showing Arduino day 2026 on the screen. So as mentioned here, this is the document. I will share the document link as well in the chat box so that it is easier for you to go through. We have multiple experiments mentioned here, and you will have all the details of the experiment, the component that will be used in that particular experiment, the aim, the circuit connection, the detailed explanation of the code which will be used for that particular experiment, and then the output of the experiment. So we are giving a GIF animation with this output, and at the bottom we are also giving the assignment for you so that you can challenge yourself and make sure that you are actually learning from learning something out of it, and making completing the assignment part. Okay. Anyone have doubts? Namita Janaikar.
Sir, 1 minute.
Okay. Anyone else have a doubt? If they can raise their hand or unmute themselves and ask the question. If not, they can also write in the chat box as well.
Sir, I have connected this buzzer to Arduino. Then why it is not working?
Can you share your screen from the system that you are using? That will be easier for us. Okay. So, in this experiment, what are you trying to? What is your aim for this experiment?
The buzzer should work.
Okay, but based on what?
Just means continuously it should beep or
Right. Okay. Then you can go to the code section. Yes. Right. Then you have to write the code here, right? Electroblocks is where we just control the blocks, but in here in Arduino on cloud, we have to write the code from on your own. So you can write. So in terms of LED and buzzer works the same way. You can in the platform that we have shared, the Google Doc. Yeah, right. That's the right code. You can just take the reference from it and write your own code for the buzzer and try to simulate the code.
okay, sir.
Yeah, sure. Yes, anyone else have a doubt? Schools, teachers, you can ask the student and you can ask them to unmute. You can unmute and then they can ask the question. Okay. Yes, Neelam, you can ask the question. What is the difference between digital pin and analog pin? Okay, so this is a nice question. So digital pin is so there are sensors components that comes with the value of 0 and 1. So whether it is high or low. So those components like let's say a PIR sensor or let's say a servo motor, you can just make sure that whether the motor is on or off. You can light huh. So let's say there is a LED that we explained. You saw that I had connected to pin number the digital pins pin number 8. So that is where the high or low control command will be done. But when I connect you to the analog, I can't just write high or low. I have to give a specific value which is understood by the Arduino, the controller, which is 0 to 1023, like the way I explained for the potentiometer. So that is the analog sensor. Those sensor which operate with the value of analog from 0 to 1023, those sensor will be connected to analog pins, and and the sensor which are controlled on the basis of high and low, turn on and turn off, those sensor will be connected to the digital pin of Arduino. ते झालं पण okay. Have any questions from the students? Shall we move ahead? Yes, Aarti. You can unmute yourself and you can ask the question. Yes, Aarti. You raised your hand, right? You have any doubts? Okay. Okay. So we shall move ahead to conclude the session. For firstly, I will ask the teachers to make sure that the feedback form which has been shared with you over the email, you, you have to complete it. You also have to click. Sorry. You also have to click few pictures and upload it on the drive and share that link in the Google form. The students list we also require a student, number of students and students name in the feedback form. So the feedback form had been shared with you a couple of days prior to this. We kindly request you to fill out that form. And we encourage all the schools to come forward, and if they have the idea of implementing a lab inside their school, adult tinkering lab, uh, curriculum based on the NEP to 2020. So we encourage all the schools to come forward. The FOSSEE team, the open source hardware team will be extremely happy to help you out in this. Uh, so the idea behind adult tinkering lab is making sure all the students in your school have the expertise of hands-on activity. Then the idea behind is we don't want to teach the students only. We want the teachers to have all the expertise as well, so that the learning from the teachers can be passed on to the every batch of the students that come in the next few years. So that is the idea behind this. So we ask all these schools if they have the interest collaboration with the FOSSEE team to promote to have the adult tinkering lab in their school. We will be very happy to help them. Okay. My colleague will send the feedback form in the chat box. So just wait for a few seconds. Yeah, he has shared it now. So just a reminder to all the teachers again. You have to fill the feedback form. Uh, Write the names of the students who have appeared, who have attended the session in the Google Sheet, and then share the Google Sheet with us. Along with that, we want the pictures from all the schools that have conducted the session, so that for the record it keeps in our system, and we can communicate with all the schools again for the later Arduino Day or open source hardware events. Certificates we will have after the conclusion of the Arduino Day event. We have a team who we give the data to them, and they will generate the certificate. Mostly in the first week of the in first couple of weeks of April, you will get the certificates. The assignments we have given in the the Arduino Cloud website. For each experiment, we have given the assignment, so you can try that out. So any other query regarding the Arduino session? Teachers, students, anyone? Okay, welcome. So if you don't have any queries, we can end the session now.
Can I end the meeting?
Just a second, sir. Deepak sir, just wait a second. Yes, Deepak sir, you can end the session now.
Okay.
Thanks everyone. Thanks schools, participants, and students who have attended the session. Okay, we have a question from someone. Yes, you can
So
go
my
ahead.
name is my name is Ayush from Genvik Y, and
Okay.
at first we did simulations on Tinkercad and
Okay.
another platforms, etc. And when using now Electroblocks, I'm feeling more comfortable than Tinkercad because Tinkercad have some less elements or components,
Right.
but Electroblocks have all of them. Thank you, sir.
Yeah, sure. So as mentioned in the Electroblocks demonstration, once you get the feel of it, once you are comfortable with it, you can always switch to the Python part where the Python code are shown, just similar to the C code. Okay. So if we don't have any other queries, just a second. So you can attain you can share the feedback form and write your own names in the feedback form. I guess this is Julia Lalu. Yeah, you can write your own names and complete the feedback form which has been shared with you. Okay, so yeah, so we will end the session now. It was nice conducting a session with you all. Have a great day.